This is an AIPMT question in moving charges. The question says, if in the ammeter 0.2% of the main current passes to the galvanometer, resistance of the galvanometer is G, then what is the resistance of ammeter? So first of all, what is an ammeter? Is a galvanometer, moving coil galvanometer is modified into ammeter so that it can measure the higher ranges of currents. How it is done? To the galvanometer, a very small resistance is connected in parallel called as shunt resistance. The combination of this galvanometer and shunt together is called as ammeter. Now what he is saying is, if you pass a current, total current I in an ammeter, 0.2% of the main current passes to the galvanometer. Out of this I, 0.2% of I passes through galvanometer. As this resistance is small, 99.8% of the current passes through small resistance. Both of them join here and again it becomes R. That's how the ammeter works. It bypasses the large current through shunt so that galvanometer is safe. If that is the case, it's very clear that the galvanometer and the shunt resistance are parallel to each other. That implies voltage across the galvanometer is voltage across the internal resistance. What is the formula for voltage across the galvanometer? Is Ig into G. This is IR. What is IR? If you call this as Ig, this IR becomes I minus Ig because current is shared between these two. I minus Ig of resistance R, that is shunt resistance. But it is given that Ig is 0.2%, that is 0.2 by 100. Let the resistance of the galvanometer is G as he has given, equal to I minus Ig means, as I said, 99.8%, that is 99.8 by 100 of resistance R. See, I have just applied this data. This 100 and 100 will cancel. This implies the shunt resistance is 0.2 by 99.8, that is 2 by 998, that is 1 by 499 ohms. That is the resistance, shunt resistance. This is shunt. But in the problem, what he is asking is not the shunt. He is asking the resistance of ammeter. Once if you know the shunt resistance, what do you mean by ammeter? Ammeter means galvanometer plus parallelly connected shunt. So if you want to see this combination, this is what do you mean by ammeter, this yellow shaded part. So how can I get the resistance of the ammeter? That is resistance of galvanometer and shunt together in parallel, that is G into R by G plus R, because they are all, both of them are in parallel. So resistance of G is G. Resistance of the R we have already calculated as, say 0.2 by 998. This G is there, I have forgotten that G, this G is there, G is not cancelled. So G into G by 499 by G plus G by 499. So that is G square by 499 divided by 499 plus G, 500 G by 499. 499 gets cancels, 1 G cancel, the remaining answer is G by 500. So the resistance of the ammeter is G by 500. That's how we solve. So we are using a very basic concept of ammeter. What do you mean by ammeter? Is it's a small resistance connected, shunt resistance connected in parallel to galvanometer, moving coil galvanometer. Even the next problem is also of the same type. Look at this next problem. This is also an AIPMT problem. It says the resistance of an ammeter is 13 ohms and its scale is graduated up to a current of 100 amperes. That means it can measure a current of 100 amperes. After an additional shunt has been connected to this ammeter, it is possible to measure 750 amperes to this meter. Then what's the value of the shunt added? So what he is saying is the same. There is an ammeter. It is able to measure some current. To that ammeter, some shunt is connected so that it's now able to measure a larger current of 750. Now what happens is, when you pass a current I, if the current that is passing is I ammeter, current passing to shunt will be I minus I ammeter. Again, as I told earlier in the previous problem, these two are parallel. So voltage 1 equal to voltage 2. Voltage can be written like I ampere and the resistance, I ammeter, and the resistance of the ammeter is I minus IA and the resistance of the shunt. Right, but we have to calculate that resistance of shunt. I ammeter is given for you as 100 amperes. Resistance of the ammeter is given for you as 13. I minus IA becomes what? The total I when you add a shunt is 750. Minus IA is 100. And shunt resistance we have to calculate. The shunt is 100 into 13 by 650. 52s and 15 13s. 13 will cancel 50 13s. So 2 ohms is the answer that is remaining. That is the shunt that is connected. So both these problems are depending on a very core concept of ammeter. That what do you mean by an ammeter is a modified version of a galvanometer. The problem with the galvanometer is it's very sensitive. It cannot measure high currents. To measure high currents, to that a very small resistance is connected in parallel. Therefore, even when a large current comes, galvanometer has a smaller resistance, higher resistance. Shunt has a smaller resistance. These two are in parallel. As they are in parallel, V is same, that is IR. So I is inversely proportional to R. As shunt resistance is much smaller than the galvanometer, current passing to the shunt is much larger than the current passing through galvanometer. Thus galvanometer is protected. And of course we are still able to measure high current. That's the reason how that's the way how galvanometer works. As in both the cases it is told as they are parallel, voltage is same. As voltage is same, we could apply the basic concepts and solve the problems. That's how we have to understand the data. Thank you for watching.